Thank you, everybody, for joining us today for our webinar titled Migrating from AutoCAD to Revit Structure, the Why and How. So as you can see there, this is the first part of a six-part webinar series that we're putting on over the next couple of weeks, covering all things Revit Structure. So thanks very much for your attendance here today. So the agenda for today, so we'll be kicking off just with a bit of an explanation of why we use Revit for structural engineering and drafting. And we'll also just walk you through a typical Revit structure workflow. So obviously everybody uses slightly different workflows, but this is a typical workflow that a lot of firms are starting to adopt. We'll show you a live demonstration. So we'll show you some really great features that provide a lot of benefits when you are sort of moving from Autodesk up to Revit, or not moving from, but adopting Revit as part of your overall workflows. We'll run through some tips and tricks to actually help you migrate. So one of the biggest things we deal with is how do we go through that change management process to adopt Revit as part of our workflows. So we'll talk a little bit about that, as well as the support that CSS Civil Survey Solutions can provide through that process for you. So as quick introductions, my name is Ben Hipsley. I'll be hosting the session today. I'm very ably supported by my colleague Asif Khan, who is a structural application engineer with Civil Survey Solutions. So he is very credentialed, spent a lot of time in the industry, spent a lot of time using AutoCAD and Revit. So he'll be a really good resource to walk us through the technical presentation today. So to kick things off, let's talk about why so many structural firms are making the move from AutoCAD to Revit or adopting Revit within their workflows, and what you stand to gain by doing so. So first and foremost, Revit dramatically reduces errors. So with AutoCAD, you're constantly working in a 2D environment. So that means all of your sections, your elevations, your details, they're being manually created and maintained. And then as soon as your engineer asks for even just a small design change, it often requires multiple manual updates across different drawings. And I'm sure we can all think back to plenty of examples of how that can lead to human error and inconsistencies. Where in Revit, everything's part of that single coordinated model. So you make a change in one view and it will then get updated across your entire drawing set and 3D model automatically. So that leads to directly into improved communications. So Revit's 3D environment allows for clearer design intent. So whether you're collaborating with other engineers, with draftsmen, with architects, with fabricators, or even just the general public, the visual representation of a 3D model just makes it so much easier to spot issues early on and ensure everybody is on the same page. But it's not just about the visuals. So Revit models carry an enormous amount of structural data. So every structural element has built-in information such as materials, volumes, mass, identification codes, and a whole lot more. So this improves the data accuracy, and it's going to mean that your schedules, your quantities, and even your annotations, they're all being generated directly from the model. They're not being manually created. So workflows are also streamlined. You'll shortly see from Asif in his technical presentation that from design right through to documentation, everything lives in a connected environment. So that means there's faster design iterations, there's more efficient detailing, and you've got the ability to generate automated documentation that requires minimal to no rework. So collaboration is another major benefit as well. Tools like Revit work sharing, it allows multiple users to be working on the same model in real time, regardless of their location. So this creates a more integrated design environment, and it eliminates the traditional back and forth of exchanging DWGs. Perhaps most importantly for your bottom line is Revit just saves time and it reduces the rework. So you can see significant time savings in documentation production and issue resolution. Design speeds are also significantly improved. And with the better coordination and early clash detection, you avoid costly surprises late in the process. And we've already seen here today that most people here on average are spending 40 to 50% of their time on rework. Imagine if we can bring that down even by 5, 10, 20%, it can make a major difference to our overall workflows. And then so as you can see at the bottom there, the end result, it's faster, higher quality document creation, it's fewer errors, and it's more time for actual design. So how does this translate to tangible benefits that you can actually realize? So firms that have adopted Revit in their structural workflows have seen up to 50% reduction in the time taken for design and documentation, and then up to 90% fewer coordination issues. So whether you're a designer, you're a project manager, or you're even a company director, there are efficiencies that can have a significant impact in the quality of your projects and the efficiency of your work. So when we look at a typical structural project lifecycle from initial set out and design through analysis, documentation, and then the final delivery, what we often see is a series of disconnected tools and processes that are in place at the moment. So that's where Revit and then the wider Autodesk ecosystem can offer a really major advantage. So as you can see, Revit's not just a standalone modeling and drafting tool, it's actually the backbone of that entire integrated workflow. So there's a number of different ways to integrate it into your workflow, but when it's used properly, it really does become a crucial hub for your project delivery. So in the early stages and in the set out phase of your projects, many firms are still using AutoCAD to generate site layouts and preliminary design drawings. So Revit can actually easily bring that information in. So DWG files drop straight into the model and it allows you to use AutoCAD for what it's good at, while then transitioning smoothly into that 3D BIM environment with Revit. So for those of you that are hesitating to make the move to Revit because you have years or decades even of experience and IP built up in AutoCAD, that's certainly not wasted. In fact, it's actually further leveraged by Revit. So if you have a bank of, say, standard details in a DWG that you're using for all of your projects, again, they can be brought directly into Revit, and then it complements the rest of your model and your document production. And finally, if you're required to provide DWGs to your client or PDFs, if that's your final typical deliverable, then a Revit workflow certainly does not prohibit that. That is why I've included AutoCAD in the final stages of this typical workflow as well. So you can obviously generate PDFs directly out of Revit, but you can also push that out to DWGs as well. So for structural analysis, so Revit integrates with Autodesk's robot structural analysis and also structural bridge design. So these connections allow you to take the model you've already built in Revit and then run structural simulations and code checks without starting from scratch. So you're not duplicating efforts and managing disconnected models. What's more is that if you determine through these analysis checks that design changes are required, you can actually make them in, say, robot structural analysis, and that design change will be reflected back in Revit. So you're not using a completely independent model or spreadsheets or anything like that. Any design changes the engineers are making in their robot models are automatically translated back to the Revit model, which is really great. So when it comes to documentation, Revit is it's a powerhouse really for generating coordinated drawings, schedules, and details. You'll see that in a minute or two, but it doesn't just stop there. If you're moving into more fabrication and shop drawing production, Revit works seamlessly with another product called Advanced Steel. So that allows for model-based steel detailing, connection design, and even automated outputs for CNC files. And then finally, for project delivery and collaboration, tools like ACC, the Autodesk Construction Cloud, can come into play. So you can publish Revit models directly to the cloud. You can share them with stakeholders. You can manage markups, RFIs. You can even coordinate clash detection. And that's all from a central, accessible platform by your entire team, as well as external stakeholders. Okay, and so look, let me, sorry, just see, that didn't click over slide. So what's powerful about this entire ecosystem is that all of these tools are actually included in the Autodesk AC collection. So you might have seen a lot of these tools and thought that adopting all of this is very costly, but actually the AC collection provides really good value. A lot of you are actually already using the AC collection, so you might not even realize that you do have this entire workflow solution available to you. You can still continue to use spreadsheets, SpaceGas, Strand, all these other programs, but there is great functionality within an Autodesk suite as well. So look, that's enough for my slides for the minute. We're going to jump into a live demonstration just to show some really great examples of what Revit can do. So without further ado, I'll hand off to my colleague Asif Khan and let him share his screen and he'll take us through some demonstrations. You should be right there, Asif. Yep, great.
Yeah, thanks, Ben. Good afternoon, everyone, and welcome to the webinar, Migration from AutoCAD to Revit Structure, the Why and How. My name is Asif Khan. I work as a structural application engineer in CSS. Like many of you, my journey with AutoCAD started way back in 2005. In the year 2017, an incident completely changed my perception and workflow to use Revit over AutoCAD in structural projects. In the question of why we migrate from AutoCAD to Revit, I'm not going to explain it to you right now. Instead, I'm going to show you something and you'll get the answer to the question why as I proceed. Now, without further delay, let's get started. As you can see, this is my Revit welcome screen. I'll start a model with a new button. Once I click, it will be asking me to choose the template file. Now, the default template file in your system may have something different. Mine is a bit of different, probably from yours. Now, structural analysis and default, probably that's the most suitable thing to show, but I'm going to use a CSS structural template because I have in my template, I already have developed over here, and I included all the Autodesk Australian content in this template so that I don't have to just wander around and looking for where can I find this. Or if you're using the default template, then you may have to go through those installation, then reloading and uploading and many different things. That's why I'm just keeping it short, and I'm using CSS structural template and press OK. Once I press OK, this is the Revit environment, and the background in white you see, it's my drawing view. Now, if I try to compare this with AutoCAD, we usually draw in the model space. So just comparing to this is my model space where I'm going to draw everything, and then I'm going to do my documentation. Now, as you know, every structural project we go for the grid line. Now, without grid line, it's really difficult to locate the column position, and people will be working on site. They have some sort of difficulty to lay out. All right, so if I go a bit of background about how do we create those grid lines in AutoCAD. So definitely we'll be drawing, first of all, we'll be creating layers, and then layer a line style, then line thickness, then we'll be putting some line for the grid. Then at the head of the grid, we'll be putting some circle, then text so that we can identify and assigning to those into a particular layer as it's relevant. It's a lot of job, I guess. You also went through that. But in case of Revit, let me show you how easy it is to draw grid line. I'm going to select my grid tool from the structure tab. And once I'm here, my mouse is telling me to draw grid. I can just draw grid, just 2 click, job done. Another click, and there it is. My 3 grids are ready. So if I want to draw grid on the other side, I can also go something like this. Say this time I want to go for alphabetic order. Press A and draw another grid. Now, if you're a bit lazy like me, what I'm going to do, I'll just copy those one after another, and there it is. My grid lines are done. Now, if the location setup is not correct, I'll select all the grid lines, and without any kind of move tool or even mouse, I can just move around all the objects over here with my arrow keys only. And this is the coolest thing I have ever seen in any Autodesk product, unless I'm setting up any kind of interactive mode or simulation. Just so cool. You just use your keyboard shortcut, keyboard arrow, and move around like this. Now, let's say once I place my grid line, and one thing I need to share with you, I haven't done any kind of line work, no layering system, just no circle, no texting, no orientation kind of stuff. Everything is just pretty much straightforward. Now I'll go for the dimensioning because I want to space my grids at a certain interval. For example, I want these grids at an equal interval. So if I press equal, now if I select one of my grid and use my arrow key, as you can see, I can move around, and it's just equally spaced as I set up. Now, for example, I want a bit of overall distance. Set another dimension over here. Let's say grid 3 is 1.16 meter away from 1. There you go. So that's how I set up my grid with dimensions. Excuse me. And I'm gonna drag ahead over here. And I also want to do some dimension and spacing over here. Okay, let's do selecting dimension, going one after another, and there you go. Now I have a choice to select any grid line, and it will be showing me my dimension in a blue color. So blue color means I can edit them. Let's say this one is okay, 6 meter interval. It is spaced out at 6 meter. My rest also say I also want this one as a 6 meter. Say I'm just typing 6 meter. That's it, done. Let's say I want grid C to F. equally distance again. So I'll just set it up. There it is. I press EQ, it's equally distance. And again, if I select it, use my arrow key, as you can see, all of these are working equally. So without any move tool, without any line work, I'm just pretty much easily manipulating everything with ease. Now selecting one of the grids, such as I want this spacing between C and D, let's say 4 meter. Just press 4 meter, everything is spaced out 4 meter. Now, as you can see, within just a few minutes, probably I have spent 2 to 3 minutes to do my grid setup. Now, imagine if I have to do this in AutoCAD, all those things I have already talked about, layering, line, then assigning, many different works. That's too much work for me. Let's say I want to, excuse me. Okay. And one of the greatest benefit of using this one is, as you know, that once the grid line setup is done, then we assign those circles, lines, text, and dimensions to the annotative scale so that things can come up in a proper size and shape when we change the annotative scale in the viewport, or in the when we place it on the in the sheet view. Now over here at the bottom corner of this viewport, you will have your annotative scale over here. If I just change it, say I want to go for the bigger scale. Once I click it, it automatically adapts all the annotative elements, just getting smaller. If I go for the smaller scale, everything is getting bigger. Just imagine how cool is that? You don't have to assign anything, no line work, no nothing, no texting. Just select, click, 2 clicks, grid done, dimension spaced out with the editing of the dimensions, and just so flexible to work with. Now, once I place my grid line, now the next thing we usually go for in AutoCAD, say we want to place the what is that called, column. So if I have to place the column, probably I'll be asking myself that, okay, how can I get the column data? So probably I will be going to internet searching for, okay, this is my UV, this is my other stuff, or UC, and then get the data, then draw it. Then once my drawing is complete, then place it at each and every intersection of the grid. Something like that. That's the usual approach. But now let me show you how easy it is to do it in Revit. You don't have to draw anything. Just, for example, I want to put the column over here. I'll go for my column tool from the structure tab, and that will be giving me a lot of choices over here, as I have already talked about that. I'm using CSS structural template, and I included every single Australian content that's coming from Autodesk Content Pack. In this case, for example, I'll be using some UV, let's say 360 UV. And once I come here, as you can see, it's sticking with my mouse and asking me to put my column. So I can go from grid intersection to intersection. And if you don't like this, if you're lazy like me, then what I can do, go for the add grid, select all the grid, and as you can see, my column is placed. Job done. Now, if you're not happy about the orientation, I can just press space bar. It'll be oriented in a different orientation. Now press finish and then done. Now imagine after placement, you might be thinking that, oh, some of the column I want to rotate in a different direction. Just select those and press space bar. Your job's done. Till now, no line work, no move tool, and I didn't use any kind of rotation or anything, just some keyboard, and then job done. Now, once this is done, all of a sudden I have come to realize, oh shit, probably I have to put some more grid lines. All right, no problem at all. I'll create my grid. Say I want to place 2 more grids between A and 1 and 2 and 2 and 3. Let's do it in this way. Here, there's my grid. Rename it to, let's say 1.1. I'll place another grid like here. Let's say this is 2.1 because it's coming after sequence 2 to identify it later on. I'll push this back so that it doesn't interfere. That's it. So once this is done, now if I select any of my grid, there will be a blue colored, these are called temporary dimension, which will be active once I select any item. And I can even say whatever I don't have particular in my mind. Let's say it's 3.5 meter from grid number 1. And there it is, job done. In case of the second grid, let's say I want to place a dimension, something like that, and I see it's 3.1 meter. I'll select my dimension. I'll select my grid, go to my dimension. Let's say 3.5 meter, and there it is. I can also dimension on the other side. And within just, I spent 5 or 10 minutes, let's say, without any kind of line drawing, I have managed my layout of the column properly. Now, when I talk about Revit, I always talk one thing that Revit comes with a byproduct, and that byproduct is, let me show you. If I go to my 3D view, as you can see, automatically my columns are done. I didn't do any kind of extrusion or anything, any 3D tool, but my columns are placed in between level 1 and 2. And just imagine how cool is that. So, and this is not the case. I also have my elevations are done, south elevation done, east elevation done. Just imagine when we have been doing this and we have to prepare, say, south elevation or east elevation, we have been putting the construction line, raise, and then projecting those, creating levels, and then trimming, extending, stretching, and anything. Oh, that's just a lot of work for me. And without doing anything, I have come to realize that, oh, at the background, my columns are placed automatically in 3D. And not only, but also if I select my level and use my arrow key, my columns are also following the level marking. And I don't have to do any kind of extra line work, nothing, no stretching, and it's just automatically going on and on and on. Now, for example, I'm just going back, it was at 3 meter. It's reading in meter, that's why it's 3. Now, let me set up something side by side so that you can see what is happening behind the scene. Let me set up my 3D over here and my 2D is here. So I'm working on 2D, my 3D is getting ready. If I place anything in my 3D, it will also come on my 2D. So that is the real benefit of using object-based modeling system rather than using traditional line-based drawing system. Now, one thing I have noticed that I probably have too many columns. For example, say I want to delete them, delete, it will gone, as you can see in my 3D view as well. Plus, let's say in this grid intersection, I want to place 2 more columns. Selecting columns, as you can see, it's a copy tool. We also see the same thing in AutoCAD. Just select base point, click, and job done. Copy tool works in the same manner as we use in AutoCAD. All right, once this is done, now let's say I want some of the column going to another level at the top of this level. Let's create another level. Let's go to the south elevation and I'm going to create another level, something like this. And let's say, okay, 5 meter. This level will be 5 meter. And what I want, some of my column, I want to go to the upper level. So let's say these columns are this outer column, not that inner column. And I can select this without doing any kind of line work, no stretching, no nothing, no trimming and extending. I can come around over here. And as you can see, top level, it's reading 2. If I get my drop down, it's reading 3. And my columns are following as I want. And already I have told you that you don't have to do any extra line work. Your elevation is ready. As you can see, columns are reaching at level 3. If you go to the other side of the elevation, this is also reading the correct elevation. Let me drag it over here so that you can see. Now there it is. Now there it is. My columns are going to the level 3. Now, if I had to do it in AutoCAD, probably I have to select those column head and then I have to stretch it to the next level, or extending, trimming, a lot of things I can do. But over here, this is just easy, straightforward. Select it, use the parameters, your job will be done. All right, let's do something over here. Let's say after column placement, I would like to place some foundation. Now, usually, if I go back in AutoCAD and if I think how do I do this, we'll be drawing some rectangle, then placing those rectangle over each and every column location. And then if the size is not right, not correct, again, you have to resize it. Probably you have to orient it as well. That's really too much work. But in case of Revit, what I'm going to show you, if we come to the structural tab, select isolated foundation, it's already sticking with your mouse. Now, if I select from my drop-down list, as you can see, we have a bunch of things preloaded. That's why I'm using CSS template. Without getting this complicated stuff, I'll just keep it simple using rectangular footing. I'll select it, and as you can see, it's asking me to place some footing. I'll place over here. And as you can see, it's also going on behind the scene, putting it in the 3D. And if you don't like this, if you're lazy like me, I'll go for the all at column, select all the column. As you can see, it's already placed all my foundation under the column within just 2 clicks. I didn't do any kind of line work. I didn't draw any rectangle. I even didn't rotate anything. It's following the column direction and automatically placed everything. If you're not certain about, is it the right size, you can check with your dimension. This is reading 1800 by 1200. And that's the thing we are using over here. All the data are preset and that's loaded here. All right, let's say we're going to put some foundation beam connecting these columns. Now, if you go back in memory, how do you do it? We'll be offsetting this grid on both sides, then trimming at the column at the foundation location, and we'll be doing this, keep doing this all over the place, and that's just a kind of very time-consuming process. Honestly speaking, I also have done that. Now, if I come over here, if I take my beam tool from my structure tab, I'll be given choice of lots of beam. As I said, already loaded, so don't worry. Your template might be very different from my template. Those are not, probably your template hasn't loaded all the stuff. Now, in case of here, I might be choosing concrete beam. So if I write down concrete, there it is. Concrete rectangular beam is here. I have 3 choices. I'll be using 600 by 300, which is already ready-made, made it, and all the data are embedded over here. Now, I can draw column by column to column in every single part like this. As you can see, it's also drawing in the 3D, but if I'm a bit lazy, then what I'm gonna do, select all the grid line and press finish. My column is done. I haven't done any line work yet. Everything is model based and easily followed, and size and shapes are exactly the same as I set up. Now, for example, in this project, in this example, I don't want these column. I can just select those and delete those. There it is, done. My layout is ready, and I can put it on my sheet and then forward from there. Now, before I go to sheet, I want to create some framing, for example, at the top of this column. So I'll go to the next level, 3, such as like this. I'll put it on this side, and so that I can see what is happening behind the scene. So over here, when I come back, let's say I want to place some beam. Look at the beam tool, and I want to put some UV. So there are heaps of beams loaded of this U and V to search for. We're filtering out and we're taking them into the UV section. Well, there it is. So from the UV, what I'm going to do, I'll use 250 UV, for example. And again, I can draw column to column, but instead, what I'm going to do is the on grid, select all the columns and grid, and there it is. Just finish, job done. Just 2 clicks, everything's done. Now, if you try to remember how do we do it in AutoCAD, we used to set up a layer, Then we used to make a line thickness, proper line thickness, probably the line type as well. Then draw this line, assign to the layer, and do a lot of stuff. And that's just heaps of work for me. So just 2 click, my job done. You can see in my 3D it's done. And as a byproduct as well, my elevation is also reading the proper height and depth of the column. If I go back into the other side, you can see this is pretty much done. Now over this, what I'm gonna do, let's say if we have to represent the actual size of the beam, we have been copying these, offsetting these, then trimming on different locations, and then copying. I mean, that's just too much work. So what one of the most greatest benefit of this one using Revit, that you can change your level of detail. For example, it's now coarse. If you change fine of level of detail, it will show you exact size of the beam. So I haven't done any line work yet, no extra work, no offsetting, trimming, no movement, no nothing, no rotation, and everything is done pretty much automatically. And this is the industry standard presentation we usually do when we work in kind of framing layout. Now, for example, in this case, I want to go for, let's say I want to place some beam at the top of this tall columns. So I'll go to my level 3 plan view, which is not registered over here. I'll go to the view, then plan view, structural plan. This is the level 3 I want. It's coming on the other side. We'll drag over here so that you can see side by side. Now I want to place some beams at the top of this column. Again, I'm taking some beam tool, connecting from column to column. And now let's say I want to make something different. What can I do? I don't have anything in my mind, but let's split the beam at the center. So I'll come over here, taking my split tool. As you can see, all of the beams splitted in two parts, and I can select one of my beam, and the end point I want to hide on the other end, like 1.5 meter. I'll set it up something like this, 5, and there it is. I have made an industrial kind of portal frame over here just by manipulating, drawing some beams, splitting up, and then manipulating the end. The job's done. Now, as you can see, if you're not happy about the connection, we have dedicated connection thing over here, which is a topic of another day. I'm not going too deep on this. I'm going to the modify panel and click on beam column connection. As you can see, there are 2 arrows here. I'll just push it in, push it to the other side. My migrate connection is done. And I'm so happy about what I get. Now, as you can imagine, I'm definitely going to copy this, select these 2. I'm going to take my copy tool, this end to this end to this end. There it is, my industrial frame plus my flooring system. Say this is a part of the industrial building. This is some sort of facility over here, and that's done within just very few minutes. And if you can remember, our elevation drawing is already prepared without doing any kind of extra line work. I can go to different side view, and as you can see, it's already done. So in AutoCAD, we have to draw this manually. We have to project those. I mean, that's just too much work. I don't want to talk about those stuff. Okay, let me close over here. And yeah, right now, let's say I want to draw some purlins on this rafter. So to do this, as you know that we need to do series of purlin to do this. And we have a cool tool here, which is called beam system. I'm going to take my beam system tool, and that will be asking me to draw. As you can see here, it gave me a bunch of drawing tool. I will select the rafter top as my reference, and then I'll take my rectangle tool and select one corner, and I'll come up on the other side, and there is the endpoint, and that's it. And within this boundary, I'm gonna make some beams automatically. Now, one thing I need to to talk about that, you can even drag it outside the boundary, and you have the option to choose the dimension. Let's say it's 500. I'm going to set it 500. Let's say this one, drag it, it's 500 too. Now, you can see there are 3 lines, and this is basically guiding me that what will be the beam direction. I don't want my beam direction over this, but on the other side. Select beam direction, click over here. That's it. You press finish. There it is. My beam placement is done. Now, as you can see, I have placed wrong beam. That's okay. Don't panic. Nothing to worry about. I can select my beam system over this pattern section. I can set up my I can adjust some sort of setting. Let's say the beam spacing I want 600 mil. There it is. I want my beam type some sort of light gauge. I believe that L120 something. Yeah, there it is. It's loaded. That's why it's coming. Probably in your system, it's not loaded, so it will not come up on your system. So let's say one LL102, and there it is. My purlins are placed properly. I want to turn off my theta line. Yeah, there it is. Now you might be thinking, oh, it's going downward. That's okay. We can put it upward. We select all the beams. And then on the Z justification, it's reading actually top of the beam cross section. I want to place it at the bottom of the cross section. And there it is. My job's done. No line work, no nothing. If I go back to my south elevation, as you can see, my cross sections are reading exactly the same that I have chosen. Now, from this point, you can imagine, how do I go to the other side? Mirror tool. I will select the beam system and go for the mirror tool, and that's just placed easily on the other side. Now, if you're concerned about the cross-sectional rotation, in this case, that can be controlled very easily. This is the beam system. If you double click, it will open up. Because of this triple line over here, I can transfer it on the other side. Beam direction over here is okay. Now my beams are oriented in a different direction. Sorry, my purlins are oriented in a different direction. If I go to south elevation, as you can see already, I have done my 3D works. My 2D work is done without doing any single line works. Just imagine how easy it is to work with Revit over AutoCAD. Now, let's say I want to place some floor beaming on this part of the structure. Then what I'm going to do, I'll go to my level 2, turn on my line option. I'll turn off all the others. And let's say what I'm going to do, let's put some flooring beam over here. I'll use the same beam system. And once I come over here, as you can see, it's guiding me that the beam system tool is so intelligent, it can detect the close boundary surrounded by beams. So it is guiding me that where do you want to put the beam? So in short direction, in longer direction. But before I place it, I need to change some setting over here. Let's say I want 1 meter spacing. And beam type, let's choose some smaller beam type, like 200. Now I'll go for the shorter direction. Here, as you can see, my 3D is done, my 2D is done. I didn't do any line work yet. I want to place more floor beaming. That's done. Over here, let's say I want to place into different direction. Over here, there it is. There it is. My job is done. My 2D standard representation is done, as well as my 3D is done. Now, I just kept, I could put some more flooring. Let's say there is something going on. It's an industrial facility. I don't have particular anything in my mind, but let's say there's some sort of object, or there could be some sort of huge tank. I don't know what the tank is going to use for, but let's say there is a tank, and if I have the model ready, I can just chuck it in and put over here, do my documentation. Or if you don't have anything ready, you can still communicate with engineers by just doing some line drawing. Let me do it. I'm taking my detail line, choosing my line style, say over here purple. I'll go for circle, and I'll try to draw something that could mimic that. There's something which is called tank. probably a circular tank. And I can also feed some information over here. For example, I'm going for the text tool. I'll go for, let's say, notation tank. It's waiting. The weight is, it's a 15 ton. So there's a 15-ton tank coming over here. That's why we don't put any beam. Engineers is going to understand, okay, that's a facility and we have to design the support system. I can also just select them, drag them, and coming over here, there it is. So my presentation is done. Everybody can read, everybody can understand, okay, I cannot see anything in the 3D, but there is something going on this part of the structure. Now, if I go back to my foundation level, now it's time to put some sort of marking. Now, we don't say this marking over here in AutoCAD, in Revit, we say tag. In AutoCAD, if we have to mark this element, then we'll be putting some text, writing down, then copying from one place to another, putting again some text for the foundation, for the beams and other stuff, and that's just too much work for me. So instead of this, what we can do in Revit, we can tag them all. If I open my tag all from the annotation tab, now it's asking me that what kind of item do I want to tag? I can tag single item, or in this case, I want to go for, say, multiple item tag. Let's over here, column, foundation, framing, and once I press apply, it automatically detects my item and places my tag just automatically. So just imagine how cool is that. You don't have to do any kind of texting, writing down, then use the text height, use the annotation, assign the annotation scale, nothing. It automatically takes it and put it at the relevant position. Now, because of this automation, the foundation tags are coming at the center. So what I can do, I can select all, then I nudge it, move around somewhere, someplace, so that it doesn't overlap with other tags. And there you go. If I think my tags needs to be moved from the for the column, close to the column, I can just nudge around. And there it is. My representation is done without doing any kind of texting. I just managed to put every tag automatically, and they are just reading exactly the same information that is coming over here with my object. Now it's time to place some more tags on level 2. This is my framing. I want to tag them. As you can imagine, I'll tag them. I'll bring the tag all window again, and then structural framing tag. Okay, job done. Now, if you're fussy like me, sometimes I need to do something like, okay, I do move around, otherwise I'm not feeling good. And you can play this all day long. No worries. Now, let me show on level 3, the same thing I can, the same tagging system I can play. But as you can see, some part of the structure is not visible over here because of the view extent, but it exists in 3D. Now, I can change my view extent a little higher so that I can see all. There it is. Now I can use my tag all button again. So framing tab, apply, okay, there you go. Now, if the tags are coming over one another, what I can do, I can select all these items. I can filter out which item I want to select, these tags. My rafter tag, I don't want to select them. I'll deselect these and then move around over here. There you go. So I even didn't use my move tool at all, but yeah, move tool exists over here, as you can see there. But with my arrow key, I just completely made up everything as I want. Place the tags at their relevant location, not to overlapping with each other. And as you can imagine, my plan views are done. Now it's just waiting to be chucked in the sheet and then send it to the engineers, and then they will verify and send it back to you. Now let's do something that we can put something on the, okay, let's do some sheet view. right click, new sheet. I have a bunch of preloaded sheets over here. I'll use one sheet only. There it is. Now just select, drag and drop, job done. Imagine when we have been doing this in AutoCAD, we have been taking a view, putting a layout and a template from, a layout from template, then creating the view window, then placing them, setting annotation scale. I mean, that's a lot of jobs, I think, for me. That's why I want to make it easy. Just create sheet view, just place the views, job done. I'll create more sheet. Over here it is. I'll place my level 2. Say it like this. I'll go for the new sheet again, another sheet. I'll place my level 3, something like this. Place my some elevations I want to place in the sheet view. Let's do it. Such as I want to place some south elevation, some east elevation, and that's lining properly. And I didn't put my section yet. There is no section I have assigned yet. Let's say I want to make a section right through these tanks where they are located. So I'll take my section tool, which you can find in the view tool, and let me change it to different arrow style. And there it is. I'll change my view section extend up to here, and I'll break the section line over here. And there it is. My section is done. As you can imagine, I just draw it behind the scene. It already created a section view for me. And if I have to do this in AutoCAD, if somebody said, can you prepare a section over this position, I have to probably do the projection line and other stuff, then beam bottom, beam top. That would create a lot of jobs for me. I mean, more jobs for me, rather than finishing up the project as soon as possible. As you can see, it's done. Now it's time to place in the sheet. This is my last sheet. I'll put some section over here, drag and drop. It's aligning with the same location of my south elevation, and place it over here. I may change my section. I'll call D. Section D, it's reading D. Now, if I select it, I have preloaded view title over here. If I just switch it, read section DD. If I change from D to, say, Y, it will read automatically section YY, and it will also reflect over here section Y21. All right, great. I'll take a last sheet where I can put my 3D so that I can present my design. It's a 3D as well. Now, the 3D view, check in. If you're not happy about the scale, select it. Go for 1:50 scale, the higher scale. And I'm not fussy about those lines just coming right now. Just want to place it, just demonstrating how to do this. And there it is. My 5 sheets are ready. All the informations are over here. Just one information missing, possibly, which is, we call it schedule. I want to create some schedule for foundations and columns. Let's do it. But before I do it, just imagine if we have to do this schedule in AutoCAD, we have to draw the table, then we have to fill up the table header, column header, then each and every cell counting how many things are over here, what are the item numbers, what are the names, and everything is just so much work to do. But over here in Revit, it's just pretty easy. You don't have to manipulate anything. Let me show you how to do this. There is a schedule section, right click and say new schedule. You find your proper category, which is structural foundation. Press OK, and it will be asking me to put the column header as a field. Let's say type. I want some type, which is the name of the item. I'll put some volume plus counts. Definitely count. I want some count. If you have some comment, you can add it. Once this is done, press OK, and it created table automatically without doing any kind of extra work. Just you can imagine that these are counting every single item. So I want to reduce it by sorting and grouping, which is counting over here that itemize every item. I don't want this. I want to sort it by type and then press OK. There it is. It's just collapsed into one single row. And if I drag it, structural foundation schedule, if I drag it over here, do some organizing, and it can this table can read every single structural foundation that exists in this 3D environment with their proper name, volume, and counting. So there is a less chance of getting mismatch on any information. I want to do the same for the column. Basically, I have two choices over here. What I can do, right click, and one is graphical column schedule. This is just one click solution. I can click it and there it is. My graphical column schedule is ready. Sometimes people like it, sometimes people doesn't. It will show you much more data that which grid line from where to where it is extended. Now, if you like this, you can just come over here in your sheet view, just select these graphical column schedule and check in, job done. If you don't like it, you want to do a table like this, you also have the option, go to the go to the schedule, new schedule, look for, where is my structural column over here, okay, and then it will be asking me what type of field or the column head do you want to place in your table. Let's say I want some type, I want some counts. There it is, counts. I want some length information. We'll go for system length. I want system length above my count. I want some top level, top offset, plus say bottom level, bottom offset, and there it is. And if I press OK again, it will be giving me a big list. So I'm not going there. I'm just minimizing every instance to count on the table. Now sorting by type, second sorting by system length, for example. If I press OK, there it is. My column schedule is ready. I didn't draw any table. I didn't fill up all this information. The header, the column header, and all the cells are coming automatically. It's detecting this information from the 3D model and putting it into my schedule. Just so super easy to work with Revit. Now I can select it and bring it over here. And there it is, my column schedule and foundation schedule ready. And that's it, done. So information is flowing very smoothly over the system. If I change any column, it will be reflecting over here, which I'm going to show you within a minute. But before that, let's say I want to place some schedule for this framing over here. Now, if I go, I already have built up a table in my template. That's why I'm not doing the same thing over and over again. I can just select it, drag it over here. There it is. All my columns are located, and anything exists in this 3D, it will be listed up on your table. For example, these columns are not used for the floor framing. These are concrete columns. You have two choices. You can split this table and put this concrete column in the foundation layout page, or you also have the option to select all the foundation. Let me show you. And we can use some sort of comment, such as foundation beam. By this way, it will read which beams are foundation beam, so that people working on site, they know that, okay, this is not coming for this part of the structure. This is the foundation beam. We have to put this foundation. This is the length. This is the count we're looking for. And just super easy it is. Now imagine I have spent, Ben, you're definitely here. Can you just tell me how much time it would take to prepare this kind of detailing in AutoCAD?
Oh, you'd be looking at a good week or two before getting to this point, and you, certainly wouldn't have the function and the dynamic, base of the drawing set that you have here.
Exactly. Now, I didn't use my count. How much time did I spend to do this till now? Can you just tell me?
You're sitting at about Yeah, 30 to 40 minutes in.
30.
Yep.
Just imagine within 30 minutes, I have done 5 days of worth work within just 30 minutes. If I spend my 8 hours of a day, I can prepare all the necessary detailing for this project. And this is the reason why you should migrate from AutoCAD to Revit. I didn't wanted to answer this one before because I wanted to show you that why should you migrate from AutoCAD to Revit in your structural workflow. All right, perfect. Now my 5 sheets are ready. Now I can just print it out, send it to the engineer, and probably the engineer will say, oh, I can imagine there's something going on. So can you change something for me? Oh yeah, sure. Why not? What do you want me to change? Now probably the engineer came to me and said that there's a heavy load going on, so I need to increase my foundation. All right, perfect. I can change it later very easily. So before I change, I need to show you something. Let me set up everything so that you can see real time what is happening. I'll go for the foundation sheet. Let's set up. I'll move it down. I'll set up to foundation schedule view. This is my little one. And this is my 3D. If I do it in this way so that you can see what is going on, change one more time. This is my foundation schedule. This is my 3D. And now, as per engineer's requirement, I want to change these foundations. So this 6 foundation needs to be bigger. If they have specified anything, I can just select, I can just create more data over here and then input the information, or pretend I want to select this bigger size of the foundation. And just keep your eyes on this table plus this tag. I know it'll be hard to keep eye on both part, but just have a look what happens when I make the change. Once I click over here, I got my line drawing on my 2D plan increased. I have my tag updated, plus there was one row of the data over here in the foundation schedule. It created second row, and I didn't do any kind of manual work of text manipulation, line drawing, extending these outer extend, and I didn't even touch my table at all. And this information is flowing smoothly from one within this system. And this is the efficient information management system. If I change it over again, then it's going to count differently. It's going to show me if I have any other foundation size, you can select it, and it's going to show me everywhere that exists these tags, these schedules, the size and shape, everything will be updated automatically. And this is the answer of that why, which I haven't told you. All right. Okay, let's do some, let's say my engineer also asked me to change some structural columns. Okay, let's do it. Let's say these columns needs to be changed as engineer requested. Select these columns. Again, keep eye on this structural column schedule. I go over here, keep eye on this tags. Say engineer asked me to change it to the bigger size. So I'll go for 60, for example. Once I make the change, look what happens on the table and the tag. Click it, another row came out, and my tags are reading the exact information. My size shape has already updated, and not only within the plan view, 3D is also updated. My elevations are already updated. It's reading the correct information of the column size and shape without touching any line drawing. I could just, with just intelligent object-based modeling system, I prepared all of this. Now, the last one, say, engineer also asked me to put some beams, sorry, not put some beams, asked me to increase the beam depth. So what I'm gonna do, I'll choose my sheet tool over here so that you can see. Over here, so that you can see clearly what's going on. Excuse me. Here, so over here, and right now I'm gonna select these and select this beam. Probably engineer requested to change this beam size to the higher beam size. All right, bigger beam. As you can see, this is reading the information from here. Let's set up this way. I put the table over here. The other side, go for my level 2, so that you can clearly see that what is going to happen. These are reading 250 UV. Now, upon changing, it's going to flow that information to my table, my tags, my model, my 3D, my 2D, everywhere. I'm going to select it and I'll go for 410 UV. And as you can see, my beam depth increased. My information, there's no mismatch on my information because I'm using 410 UV, and it also came out over here 410 UV. So this is the reason I changed my workflow from AutoCAD to Revit, and I highly recommend that you should do that. And such as one last thing I want to talk about. Let me close all these windows, which are getting too much. And once I have done that, my if I go to the section view, as you can see, my beam depth is also increased. So just I want to put some dimension over here and talk about something. Let's say there it is. Now imagine that within this all work, if I'm working in AutoCAD and I have changed my text, I have changed my line on the plan view, and unfortunately, I forgot to change my beam depth, and this beam depth is reading wrong information. And I send it to the MEP engineer. MEP engineer didn't even bother to look at what is the beam you're using, and probably in AutoCAD I haven't changed this beam size, and they have been thinking, okay, beam size. I have this information over here. I can use the invert level of the pipe somewhere else, and when everything goes on site, they see that, okay, invert level is not right. It's intersecting with the beam, and there's a clashing problem, coordination problem. They'll be talking to you, your boss, or anything. Then we have to resolve the issue and do the rework again. But here, as I change the beam size, as you can see, this is 410 UV. On the other side is 250 UV. So information is not only flowing through the tables and the tags, it's also coming to my 2D drawing, my 3D, my plan view, my elevation, every single part where the change is made. So this is intelligent information management system. Now the last part I'd like to show you. Let's say a few people represent the 3D in this way, or some people prefer in the hidden line field. So let's say I prefer doing some shading, and I want to shade this beam with different colors so that it can pop out and people can notice there, oh, there's something going on. So we have to keep eye on this. Let's say I want to change the color. Come here, selecting, clicking, will open my material, and I'll duplicate it, and I'll change my color. Let's say red, not too bright red, something like this. Okay, apply. There it is. My beam is represented with color. If I want to do more coloring, select these. Let's say I want to get some colorful low beam with the bluish color. I'm not getting too fussy about this. You can play all day long with your color as much as you want. I'll place some, let's say, these are purlins to show my purlins into different way. Excuse me. Yes. These are purlins, and select it. Go over here, duplicate, and say I want to put some olive greenish color like this. There it is. I can also do some sort of coloring on these columns, and I can just play around all day long if I want. Just finish, and let's choose it some different colors. This. There you go. Now I have made a colorful illustration. It's on my sheet. Now it's just pretty easy. Print it out, send it to the site, and job's done. Okay, I guess I hope you understood the potential of using Revit for any structural project over AutoCAD. And thanks again for joining this webinar. I'm done with my part, and I'll hand over this presentation to Ben.
Thanks so much for that, Asif. It's absolutely fantastic. It always makes me think about my 15-odd year career as a structural engineer. And if our team had spent a lot more time in Revit, then I'm sure we would have got a lot more done over 15 years. So it's fantastic to see. So look, I'll quickly just share my screen. And look, I appreciate that we are slightly over time what we told people. So I'll quickly just run through a couple more minutes excuse me, of what we want to get through today. So just as a quick demonstration summary. So we began with an introduction to Revit and just gave you a brief look into the Civil Survey Solutions custom template as well. So a lot of what you saw Asif doing was through our template. So if you wanted to get your hands on that template, which has a whole lot of things pre-built into it, let us know. I'm happy to let you know how you can get yourselves that template. We demonstrated some significant time savings in setting up grid layouts in Revit compared to traditional methods. From there, we moved into placing key structural elements, so columns, beams, footings, these things, again, showing how much quicker that can be within Revit. We highlighted some of Revit's biggest strengths, that being the ability to make design changes in just seconds, and even more importantly, those changes automatically being updated across all your associated models and drawings. Finally, we shared a few additional tips and tricks there at the end that help you not just improve the speed, but also the quality and consistency of what you're delivering. So look, the important thing to discuss now is our implementation plan, or how we can support you actually to adopt this. We understand that Revit's not a new product for many organizations, but just the hurdles and the change management process is really what stops a lot of companies really adopting Revit as a solution. So we've developed this implementation plan to really make sure that you achieve long-term success and minimal disruption through that change management process. So we'll begin with a planning and assessment phase with your organization. So that's where we'll take time to understand your existing workflows, your typical types of projects, the skill sets of your existing team members, and more importantly, your business goals over the following term. So that'll help us tailor that implementation plan specifically for your needs. So the next is we'll have a look at your licensing and further implementation. So we'll make sure that you have the right tools and infrastructure in place. So that doesn't just include software licensing, but access, configuration, setup, hardware, all these sorts of things. The next step is training and skill development. So we'll work with your team to upskill them. We'll create tailored training sessions, and we'll give them the knowledge and confidence to use Revit effectively. Now, this step is somewhat interchangeable with the following step, which is customization and content creation. So that's where we'll help you develop templates, libraries, and other settings that will align to your standards and workflows. Depending on the level of customization we identify earlier within this plan, we might go through this process before the training step, and that's simply so we can then train your users on your own customized setup environment, so they know exactly what sort of information they'll have access to through that Revit setup. After that, we'll run a pilot project together. So that's the opportunity for us to apply everything we've learned so far through this process into that real world context. It allows us to test the processes, identify improvements, and build that internal confidence within your teams. Following that pilot, we move into what we call the review, refine, and scale stage. So based on the lessons we learn from the pilot, we fine tune your setup. We do a little bit of more customization if we need to, and then we support you in rolling that out across the remainder of your projects and teams. And then finally, ongoing support and improvement. So we continue to work closely with you. You will always have access to our experts. We'll keep you up to date with how Revit evolves over time, and we'll continue to guide you along the way. So that structured approach, it means you're not just adopting new software, but you're building that efficient and future-proof digital workflow that is really going to benefit your organization. So look, what services are tied within here? What I'm going to do is I'm actually going to relate this into a few questions that we got through the session as well. So they came through the chat box. But look, I won't go into too much detail because I know we're a little bit over time, but the things I wanted to focus on is a lot of the questions I was getting through there was about things that can be resolved through customized families, through some parameters, through even some Dynamo scripts. So I really wanted to focus on what you see on the right-hand side of your screen here. We've already spoken about a lot what's on the left-hand side, but on the right-hand side, what I wanted to highlight is that we're here to support your organizations in building custom families, in building those templates and standards, in working with you on that sort of BIM workflows to really identify where you can find efficiencies and gains within those workflows. And if it does involve creating customized families, it could even be converting all of your old DWG details into Revit line work, all these sorts of things. It might sound like a lot of work for you, and you don't want to be putting your billable engineers and drafters off project work and reducing their utilization to do these sorts of things. So that's where we can step in. We can do all that work for you behind the scenes, making sure that your drafters are staying busy on billable work and remaining utilized. And then we deliver you that final product all ready to go, including a whole lot of user help, user guide, and documentation on the side. So it can be a really great way to initiate that plan and make sure you're getting a really good product that's tailored for your organization, and you haven't had to take your own users off deliverable work to be able to achieve that. Thank you everybody for attending today. It was a really great session. Thanks a lot for Asif for his technical presentation. It's just fantastic to see, what experts can achieve within Revit. In 40 minutes there, we saw essentially a whole model be built and an associated drawing package. So it's really fantastic to see. If you'd like to get in contact with us for any reason, you can see our contact details there. Otherwise, you can come through our website to get in touch. That YouTube page that is highlighted there as well. That is where this recording will be popped up in the next couple of days. So keep an eye on there, but you'll receive a notification on your email as well. So I'd just like to thank Asif again for his presentation today, and thank you everybody else for your attendance as well. And I hope you all have a good afternoon. Thank you very much.